So yeah, there is a lot of information that Arun just mentioned, which should be like digested in bits and pieces. So today there will be a lot of sessions diving into it, and we'll specifically focus on the salsa stuff. So yeah, who we are, Saiyam Pathak and Harsh, you can just reach us out. So what is salsa? Arun showcased one slide, which is a very enlarged version of the three four stuff which is mentioned on the top. So whenever you write a software, whenever you write a piece of software that goes out to the end user to be used, you write a source code. You have some way to kind of build the artifact of that, distribute it, and in the end, the customer or your end user is using that. Very simple, but there is a whole chain of events which are there, and every chain and every step which is involved, right from when you are writing and pushing the code or using someone else's library or dependencies till the time you build it, distribute it, and put that in production. So you can see, and some of those attacks were also mentioned by Arun. So you can see while you are defining the code, there is a malicious actor who wants to inject deliberately the bad code. You have the build system that gets compromised, and the famous SolarWinds attacks come here. You use some of the dependency, so unknowingly there is something that you are using and you haven't updated for a long time, and if that has some compromised code, then your piece of software also gets compromised in the terms of dependency. So with this, there are a lot of things, and that is where Salsa comes in, which is the supply chain levels for software artifacts. Basically, a lot of big organizations coming in together, defining in the industry standards and practices, and various levels. And we'll talk about each of the levels. So various levels in Salsa are there, which are kind of the incremental guidelines on how you should be writing, distributing, and building your software pipeline in the whole supply chain. And then also some of the metrics, success metrics, like how do you define whether you have reached level 1 or level 2 or level 3, and design for delivering the tamper proof software. So that is the end goal, like we want to deliver the tamper proof software to the end users. Now what exactly is the tamper proof thing? Code, how the build system would be compromised. There is this attack that you can read online, which is a SolarWinds attacks, where the attacker compromised the entire build system, and it impacted the US Homeland Security. Now, that is why we are talking about this. The impact is much bigger, and the threat landscape is evolving because the components which are involved in deploying the software is evolving. The infra layer is evolving. You have Kubernetes on top of that. Kubernetes has its own set of components. Then you deploy your own application. So the number of components are rising. The threat landscape is rising. That's why the number of security attacks which are there, they are rising. And it's not that it happened once, it won't happen again. There was in 2024 as well, where Microsoft and Google CI/CD was compromised. So you can see all the big names over there. So that is why it's important to talk about that. Now let's try to, during the whole talk, there will be a lot of terms that we'll try to simplify so that you are able to understand that. So one is provenance. So when when you have a dish in front of you, obviously there is a list of ingredients that are used to prepare that particular dish, and then there's the recipe that that is prepared. So we kind of map it in a way that for the software that gets delivered, the ingredient list maps to the SBOM, which is the software bills of material, and the recipe is the provenance for that. And then next thing that comes is the attestation. So Intuitu has defined a specification, which is the authenticated metadata about one or more software artifacts. What it means is, if you see this particular diagram, there is a statement, and then there is a payload. In that particular payload, there are two things. One, where you have whether it's a binary or what is the digest of that, and two, that define the predicate type, which SBOM type it is, SPDX, Cyclone DX, and then the predicate data for that. Everything is packaged in as an envelope, DSSE, which is basically it is signed. So signed software allows others to kind of verify that it has come from the right entity that we are kind of using this particular software. These are the salsa levels. So 0, 1, 2, 3. Now the thing over here is these particular levels are more focused towards the build side of software ecosystem, the build that we saw in the whole cycle, the first slide. But in parallel, there is also work going on for the source as well, and the other defining the other levels for other things. But let's focus on the build one, which is currently there. So Salsa level 0 means you are not doing anything. You don't have a CI/CD pipeline. Probably that should be there. So you don't do anything. You're just using your local. You're just shipping everything, and you're not worrying about whatever happens in the world. I am okay with that. So that is the level 0. Level 1. So let's try to explain level 1. The build process is documented. And generating a provenance. So I hope now you know what a provenance is. So generating a provenance and documenting the build process, if you do that, then you are your software is Salsa level 1. And there are tools that you can use. So you can use the attest. So if you're using Docker, I hope most of you know about Docker, how to kind of build the artifact using Docker. So Docker provides this flag, which is -- attest, and you can mention type provenance. So it will be able to generate the provenance for Salsa. So that's the Salsa level 1. Coming to Salsa level 2, there should be a centralized platform where you run your builds. So basically, what it means is that your builds should not be happening directly from the laptop. So you should not be building stuff. Your CI should be not be running on your laptops, and then it is going to production. So that should be used using a centralized platform that generates the signed provenance, and obviously allowing the downstream users to kind of verify it. That's why it's a signed thing.
GitHub already kind of supports this.
Exactly.
So,
Before we move further, let's try to understand what does GitHub action cache poisoning means. So what do you do in GitHub when you write GitHub actions? Obviously, you take some popular action which is out there, and the action itself has a particular repo that is maintained. Now you write your GitHub actions, you use one particular action, you build it, you release it, give it to the customer is happy. Over the time, what happens is one day an attacker comes and puts some malicious commit onto the popular action that you're using. Now you are using the latest version of that particular action. So your whole thing gets poisonous, and in the end, whatever the consumer is, and you are not even knowing that, because you don't touch your GitHub actions pipeline that much. You're using your action, everything is working fine. You just check your artifacts are kind of coming up right, but they are in the end having the poisonous cache. So that's the GitHub cache poisoning. And if we move, so Salsa level 3 means that we should ensure that builds runs cannot influence each other. And obviously, we should not commit secrets. So secret management is another thing. Basically, in the end, we want to build a secure build platform. Securing the build platform is something that should be there in Salsa level 3. Now, is GitHub Actions actually Salsa 3? So this particular diagram of GitHub cache poisoning is there. They know about the issue, but they cannot do anything about this issue. It actually depends on the producers, the producer side of things. Because the producer is creating the code, the producer is kind of writing the code and shipping and using the dependencies. So it boils down to them how they do the dependency management in the CI pipelines, and not on the build system itself. So is Docker can Docker be Buildkit be level 3, Salsa level 3? Here also Docker has cache poisoning, but they have some mechanisms that can be used. For example, you can build what you do, Docker build -t, give the tag of the image, and then you put the dot over there. So instead of using that, by providing direct git URL and performing hermetic builds, we'll just come to that particular terminology as well, and then using no cache. Obviously, saying that using no cache is good, but actually using it is not very convenient, because every time you again it's time consuming process if you do no cache. So eventually you have to use something which is cached. So Salsa level 3, again, Salsa has some levels, but it's not the end. There are a lot of things. In the end, what we want is we want hermetic and reproducible builds. So that's what we want. We want our builds to be hermetic and be reproducible. What does that mean? So in hermetic builds are kind of an airtight container. So you have the resulting artifacts which are unaffected by any external influence. So that's what a hermetic builds means. And every step, whatever is there, is documented. There is no network. Everything is mentioned, and immutable artifact is produced. Now, hermetic builds leads to the process of reproducibility, reproducible software. So this means a build process is reproducible if the same build definition comprised of immutable, verifiable references to steps, source code dependencies, the end result produces the identical result. So this is with respect to the SolarWind attacks where the build system was compromised. So how they mitigated that issue is now they have their builds running in different build systems, and they are able to generate the artifacts, and then they are able to compare the cryptographically verified hashes in the end for the particular artifact that gets generated. So if the hash that gets generated in the end is same, that means your build system is kind of safe. Can we do hermetic build with Docker? So Docker says that if you go to the Docker documentation, that you can do the hermetic builds if you do not have run statements in your Docker file, and if you have the network none flag. So let's try to understand that with the help of a Docker file itself. So this is a typical Docker file, and you might be knowing that you use from a particular base image which is there, and then you use some of the run statements. You do updates, you do a curl from a random website and pull some software in to make your software work. Whatever that is, whosoever has created, we don't care about that. We just run that particular curl command and we say that our server and the application is running. So this is a very common way. Even if you use the base image as very minimal, alpine, less CVEs, but you still tend to run those run statements because without that it doesn't work. So how would that be converted if we want to do that as part of the hermetic build is dependencies are added to the base image. So we create a base image, we create a golden base image for our application where we put everything. In the dependencies that are vendored, we just add a vendor mod as vendor. And for another one, which is the last base image, we also put everything which is needed so that it doesn't fetch anything from the internet. But how feasible is that? Is it even doable? How can you do that creation of those base images by adding your own packages that you need for your software application, and also make sure that they are less CVEs? Because in the end you want even if you are building that base image, so you will be having another Docker file where you will be having all those run statement. So in the end you will be fallen into that same loop of how do we fix this problem. And for that we created something which is called build safe.
Yeah, I was just saying that BuildSafe focuses on creating these zero CV base images. It also produces these high quality SBOM, which Arun previously talked about, that US and EU government are promoting, and also Indian government has also started promoting it recently. They set out guidelines. And the end goal for all these things is tamper-proof builds. Like, we do not want to take the risk, at least in mission critical systems like nation security, healthcare. We do not want to just leave it up for chance. And SLSA compliance plays a major role in bringing that. So today we'll try to demo how we can do practically how we can make a secure SLSA compliant build. So I'll start with moving to a regular looking Docker file which we just showed. Let me just show that. So hope that's visible. So this is a very regular looking Docker file, right? Like, you have the from statements which we previously showed. It's very similar. So let's try to change this a bit. In the level 1, what we do is we don't do a hermetic build yet. We just change the base image. So we are trying to showcase how you can use BuildSafe to make your own base images without using hermetic builds just yet. So first we create this base image. If you see on this line I highlighted, we can see that we have these custom base images. We are pushing to a ttl.sh, which is a anonymous registry. So I'm going to build, so I'm going to actually show you something I built previously, because this might take like 1 minute of our talk time. I want to show a lot of things. So if you can see this, just before the talk, I built this base image from BSF. And to show you how I did that, I need to show you the declarative file we have. So it's very easy with BuildSafe to define the dependencies you want. You can define it at a granular level about what dependencies you need in your development and what dependencies you need in your runtime. And you can differentiate this. We have a nice way to help you select and know about all the dependencies you have. We have another talk coming up later today that can focus on that side of things. But for now, we are focusing on the build side. And
So basically, the build file makes our builds declarative itself. So this is the declarative file that defines what goes inside your base image, what all packages goes inside your base image. And like Harsh mentioned, each of those packages which are mentioned can be selected based on the vulnerability level, which will be shown later today.
yeah. So we have this build block. So this is how we build a base image basically. So we just say that this is the name of the image we want, and it's very nice that we can. So OCI allows you to structure like OCI specification calls it layers. Like you can have up until 128 layers. And typically, what we do with the run statement is just squash them all together in a single layer. But since we have control now with generating base images, we get to customize how we want to layer our OS packages. So by default, what we do with BuildSafe is just we split every OS package into a single layer. What this allows us in future, when you patch the image, base image, you can just replace the one OS package layer. So this allows for really fast patching in terms of at least network bandwidth. And that's it. Like we have two blocks. One is build block and other is runtime block. The difference is the layer section where we have runtime packages itself in the runtime image, and the base image we have this. So going back to the command I ran earlier before. So in here we have BSF OCI, which is the command to build the OCI block. Build is the block we were looking at earlier. And since I'm on a Darwin ARM, and we want to build it for Linux AMD64, so that's why I provided that flag. We want to have a dedicated tag for this. So the reason we have this flag is this is very helpful in CI/CD pipelines where you want to do tag based on a release, right? So you can just practically change based on, you can pick that variable up from GitHub and GitHub workflow and plug it in. And lastly, we are just pushing that image. Okay. So yeah, the same thing. We have done the same thing for runtime as well, and we have pushed these images to ttl.sh. The nice thing that BSF does for you is it generates these attestations. Now we talked about attestations before, right? So if you look here again, we get to see that this attestation in particular. Let me scroll to the top. So we have one attestation for the SBOM. So we are generating SBOM by default, both in Cyclone DX and SPDX. And thanks to Protobomb, which is an open SSF project, we're able to cater to this need that we don't have to worry about any format that comes up. And lastly, we have the provenance as well. I scroll down somewhere. Yeah. So we have salsa provenance as well, where we have the subject, which is the base image, and we then have the predicate where we said all the dependencies that were mentioned. So now now that we have the base image, we can go ahead and build the image, right? So I've already done that as well, but I'll do it again. So as you can see, this build is not hermetic because it's going and downloading the dependencies right now for the Go dependencies at least. So once this build is done, we can see that we'll get an image out of this, and we can inspect it, whether it has provenance or not, and if that provenance tells us if that build is hermetic or not.
So the attestation that was generated was by default. So when you build the base image using build safe, you get the default attestations with it.
So I'm using this tool called Crane, which is a popular tool to inspect OCI images. So in this tool, I can see that this has two manifests, image manifests. So if you run it on a container runtime like Docker or Kubernetes, kubelet will inspect that this has a platform architecture and it will use this image to run. But for our purposes, we are looking at this image manifest because this gives us details about the other image manifest we have. So the way it works in Crane is that you can just grab this digest. You can run Crane manifest and then mention that digest. So this will give us details about the layers that are in this image now. So which is what we wanted. Now if we for a layer, you cannot use manifest. You have to use the block command to inspect it. So we'll do that. Take you that. Okay. So all we care about this is this metadata block. And if you see, the metadata block says local directory. That's all we are kind of interested in right now. That it doesn't say anything about hermetic build. It says material is false, which we'll look at in a minute, why that's critical. And this VCS information is local. Like, those are the important things we need to look at as of now. So in this level 1, we basically use BuildSafe just to manage dependencies and generate these base images. Like, this is the first basic step to kind of get into the realm of adopting BuildSafe and trying to look into the possibilities of hermetic build. And now that we have done that, let's go a step ahead and switch to level 2. And if you look at the Docker file of this, we have build image and runtime image as arguments. Can anyone guess why? So since we are talking about hermetic builds, Docker has a definition of, they comply to the definition of what hermetic is, which is knowing all the dependencies, even the source code. So a Docker build dot, like when you're building from the local directory, that cannot be hermetic because local directories can be poisoned and whatnot. Even when they're running in a GitHub action, they can be poisoned. So they want us to rely on a Git commit itself, a Git reference basically, and that's why they asked us the location for the where the VCS is, where our version control system is. So once we specify that location, it's hard for us to now change the image, right? Whenever there's an update in our base image, now we cannot go and manually keep changing this Docker file. So it makes a lot of sense for us to automate this and automate the part where we have dependency updates, generate new base images, and when these new base images are generated, we just update our workflow files with the newer tags, and making this as an argument comes a long way. So to explain this command, so the platform makes sense. So we have the network none, which is the critical thing we needed for hermetic build. We also have, so we have specified the base images as build arcs, which I was talking about. We tag the image and push it, and we specify the Git reference. So I'm going to build that now. So the one beauty of hermetic builds is it really helps with caching. Since everything is known upfront, Docker utilizes that in a really nice way and caches a lot of things for us. So I'm going to do the same thing which we did previously with the other image, and I'm going to inspect the manifest and attestation of this. So this is basically the line we wanted to have, and we now have hermetic build, and this materials true which I was talking about earlier comes from the fact that we have the Git reference. Without this Git reference, this materials would have been false. So if you go today to Docker's documentation about hermetic builds, they'll just say that if you use network none, you'll have a hermetic build. But this detail that this material true needs to be this needs to be true is something that's missing. And if you practically try it, you'll notice that even if you have network none, you'll see hermetic as false, and you actually need to provide materials true. So the other thing that is required to reach, I think that's small, I can zoom in. So the other thing that's required to reach SLSA actually is basically whatever I did here, we just need to put it in a centralized platform like GitHub Actions and run it. And one important step out of in the end that we need to perform is, again, yeah. So it's to sign the image. Without signing the image, we cannot prove that it came from us to our consumers. And for signing the image, we have this wonderful tool called cosign, which I would recommend to look into, and especially look into the keyless signing aspect of signing images. Unfortunately, we do not have time to demo that, but highly recommend to look into this, and we'll reference this example, GitHub workflow example we have on how to do a hermetic, what we think is SLSA level 3 and possibly level 4, whichever comes up in future. Presentation mode again. So we can conclude that SLSA provides these guidelines. They really want us to deliver tamper-proof software. We also see that OS dependency management is critical, and that's where tools like BuildSafe, what we're building, comes in. It helps you declaratively and in a simple way manage these OS dependencies. And for security teams, hermetic builds will help them a ton. Like, they do not have to deal with developers running run statements with that and fetching random binaries with curl commands. That problem goes away when we have hermetic builds. And it's just difficult to, in the end, it's just difficult, even after we do all this, to trust a single platform. And that's where we've seen organizations like SolarWinds have taken an approach where they diversify and use multiple build platforms and then cryptographically verify. And that kind of trust, to build that trust, we are far away from that kind of automation today. And it's critical whenever we are dealing with sensitive sectors. And that's what we're trying to aim to achieve.
Well, yeah, thank you. That was a talk. I highly recommend to check the repository because and go through that every level 0, level 1, level 2, and in the end, eventually see the whole GitHub Actions pipeline because it's nowhere to be found that how to actually do the hermetic builds. Even the Docker definition has kind of very limited information. yes, we want to do that, but how to do that eventually? We tried to showcase that, and it works. So probably something you want to look and see if you want that kind of system for your softwares and processes. Well, that's our time. Thank you, Ram, for giving us extra minute.
Hey, thanks so much for that wonderful talk. It was, I mean, what I was really looking forward to in this talk was there's a bunch of OpenSSF projects and they live somewhere, in the world. And it was really exciting for me to see that, an engineering team picked up all of those things, use those as fundamental principles. And it was amazing to see what they've built on top of it in order to realize what they've realized. And it's an exciting engineering endeavor, but it's also very inspirational to see what they've built, and a call to action for a lot of people to try and build this. And the other reason I wanted these folks on stage was, so one of Saiyam's talk was the first place I saw OpenSSF mentioned without me having to reach out to him and say, hey, can you say something about OpenSSF? So it was a very organic discovery, and I really wanted this team to be part of the SOS community day as well. So, and obviously, Saiyam never disappoints. Harsh has amazing demos. So please give them a round of applause.